Good afternoon, everybody. I am Priscilla Rigolin, and I will be the host for today. For the session, Speed and Scale Delivered, Serverless Contact Tracing Solutions. Please welcome to the stage Moha Assouli, Solutions Architect at AWS.
Hello and welcome, everyone. We'd like to start by acknowledging the traditional custodians of the land we're meeting on today, the Ngunnawal people. We acknowledge and pay our respect to their continuing culture and contributions to the city and this region. We also acknowledge and welcome other Aboriginal and Torres Strait Islander people who are present with us today. We often talk about the agility, scalability, and efficiencies the cloud brings. So today, Service NSW is going to show us how they have launched a disrupting contact tracing solution during the peak of the pandemic. And so I'm honored today to introduce our speakers from Service NSW, Carol Case and Arvind Chaudhry. So Carol is a group product manager at Service NSW, and since joining Service NSW, he has been leading the in-house product teams to design and build or deliver reusable customer-centric solutions. Carol is a proud entrepreneur at Service NSW, and he will take us through the problem and how it was solved. Arvind is the group engineering lead that led the design and delivery of COVID-safe contact tracing solution. And since joining Service NSW, Arvind has been an advocate for cloud-native serverless application delivery at Service NSW. Arvind was awarded the Digital Innovation Individual Award for his contributions. And under the product and the technical leadership of Carol and Arvind, the COVID-Safe Check-in program was a winner of the Secretary's Award for Excellence in Digital Innovation in 2020 and 2021. A winner of 2021 iTunes Benchmark Award for COVID Safe Check-ins, and a winner of 2021 Premier's Award for Excellence in Digital Innovation for COVID Safe Check-in app. So to our main agenda with Carol.
Thank you, Moha, and hi, everyone. Delighted to be here today, and thank you, Amazon, for giving us a stage. So what I'll be presenting today? Yeah, first, who we are, surely, problem statement, some key decision, considerations, how we solve the problem, and of course, where we are today. Before I start talking about problems, I just would love to say a couple of words about Service NSW, where both Arvind and I are working as a product leads. I want to present Service NSW, which is a government agency, and it's on a mission to become the world's most customer-centric government in 2030. That means putting people and businesses of New South Wales at the heart of everything that we do. Service New South Wales is the front door of New South Wales government to deliver world-class one-stop shop for customers, business, and our partner agencies. And Service New South Wales, a positive customer experience is our highest priority. We draw on the best in service delivery from the public and private sectors to provide leading customer experience through our omni-channel delivery model that consists of online, phone, and in person through our 107 service centers across the state. It was noting 77 of those service centers are located in regional New South Wales, as we firmly believe the equity and accessibility are essential in service delivery. As a product person, of course, I need to share the problem we are solving. This is where we start, and I think this is where we end up always. So I want to bring apologies because I think what we're going to discuss is probably bring some bad memories because it's about COVID tracing, and I think it's actually affected anyone, everyone in this audience. So yeah, let me take you back to 2020, the year most of us would like to forget. While COVID was raging, New South Wales government was working hard to contain the spread of the disease and minimize the impact on the economy. Keeping the businesses open had the risk of the rapid spread of COVID to the extent that it would overwhelm the hospital system and put a huge toll on the lives and well-being of Australians. New South Wales government decided to adopt the contact tracing approach, an established concept practiced by epidemiologists in public health. But the challenge was how to scale to contain, ideally achieving zero transmission in the community. Initially, government relied on a pen and paper to collect patrons' details when they were visiting businesses in New South Wales. You all probably remember these kind of dodgy papers you had to fill, right, like when you attended the businesses, and without any idea, like where this data goes, who is in control, who has access to it, and many more concerns. So among other issues, right, like it was incomplete information of the providers, lost records, because there was no centralized avenue to share it for the tracing purposes. Timely access to this information, I believe similar problem. Unclear handwriting, it's like one of the most popular. And of course, privacy breaches, to name a few. Before we start building, like we had to, evaluate our state at the moment and make sure that while we're solving the problem, we're solving it efficiently and in the right way. Hence, we had some considerations and the key design principles that we would love to implement. As we just covered, like when we're moving away from the pen and paper, so the problem space led us to the need of a digital solution to manage contact tracing at scale. We had to process a high volume of information close to real time with low latency and high reliability. The solution needed to be widely adoptable, easy to use, and respect the security and privacy of citizens' data. To achieve business agility, we relied on the modular system design practices used at Service New South Wales. It enabled us to utilize the highly adopted Service New South Wales mobile application and website with 8 million plus registered My Service New South Wales account users. The key design principles we followed were an easy mechanisms for businesses to register for COVID-safe business plan was a precondition and imperative. We had to capture only the information required for the tracing purposes, like date and time of the visit. Securely store the information in New South Wales environment for only predefined amount of time, followed by high deletion of the data. Privacy of personal information was the utmost importance for this solution. The collected data and its architecture have to gone through the privacy impact assessment and was endorsed by New South Wales Privacy Commissioner. Now, how we solve the problem. So we created a contactless, secure, and scalable check-in solution using AWS Serverless application model, also known as SAM. Our COVID-safe check-in ecosystem leverage a single platform to connect small and large businesses with New South Wales residents and travelers in a near real time for contact tracing. Service New South Wales could scale our serverless ingestion and data processing by building our check-in solution on SAM and utilizing event streaming capabilities. It enabled us to meet the high demand of application usage and ensure that it's reliable and available to everyone. As for businesses, New South Wales government created a smooth experience to register for COVID safe plan. Once registered, business obtains a unique quick response code and guidelines on how to operate safely during the pandemic. The contact tracing team used the business registration details to notify businesses about potential COVID exposure at their site. The patrons use the QR code scanner built in Service New South Wales mobile application to scan the registered QR code for check-in, check-out purposes. And finally, some user experience. So once the QR code is scanned and recognized as a COVID-safe registered business, the customer is offered to confirm the venue and the contact details. We also allowed adding dependents for group visit. When the check-in is confirmed, it could be shown to the business representative and used to check out from the venue. The platform offered check-in history for the audit and hotspot information. The venue is marked as a hotspot by contact tracing team and ingested into our platform had a red tag against the check-in history on the history tab. The system also sent a proactive notification, emails, and SMS to guest users and push notifications to the registered mobile app holders. Service New South Wales provided a guest experience for people who would love to keep their information private, and also non-residents and travelers to New South Wales to register via web interface. Now I'm handing over to the technical mastermind, Arvin, who would run us past the technical solution.
Yeah, thanks, Kirill. And hello, everyone. I hope you are enjoying the talk. Now, let's talk about the solution. Let's talk about what we built. And I tried to keep it as high level as I could. And I promise I'm not going to go into much details right now. So we talk about like serverless, scales, and volumes. So now let's unpack these things through this architecture. So what we built an omni-channel or multi-channel experience for our citizen and community. And what that means is that they're allowed to use the mobile app, and we have seen the mobile app experience in the previous slide, but they were also given a web form. So the customers who are visitor to New South Wales or who don't want to use the mobile app, they can use the web form. We also offer a plastic card to some of our citizens where some of the check-in information was stamped in a QR code, which they can take to the business representative at the venue, and they were given a New South Wales app again, which they can use to scan that QR code to sign them in. And the business representative were also given the feature where they can manually sign in a person by asking some of the details in person. So we built these different channels, and all these channels, they have their own front end and back end, and all that request goes through an API proxy, which we build on the Apigee. And that proxy provides the security, access control, rate limiting, request validation, etc. Now, all the legit requests from that proxy goes through a serverless ingestion system, which you can see in the upper half of the diagram. And we build that ingestion layer using the application load balancer, Lambda function, and the Kafka stream. And this serverless pattern really allowed us to scale to meet any spike in the traffic without over-provisioning the resources upfront. Another benefit of using the Kafka stream was that we can fan out the processing of the check-in information among multiple processes at the same time. And I'm going to a little bit touch upon some of these processes. So the one was running as a check-in and check-out merger, which is combining these two events together to complete a check-in or a visit. The other process is running on that stream of data to doing some real-time analytics. and sharing that report with Data Analytics Center. And then the third process, of course, we wanted to keep all this check-in data into the DB, and we used the serverless NoSQL offering from the Amazon called Amazon DynamoDB, so that we can easily and efficiently query the data when needed. And all these processes running as a Docker container on a serverless container runtime provided by Amazon called AWS Fargate. And I just want to highlight that this portion or this part of the solution we call it as a phase 1. It was built in just 3 weeks and released to the community. So we started capturing the customer information and their check-in details, but we also wanted to allow our contact tracing team to get access to the data. And for that, we built a self-service portal which allows the contact tracing team to request access to the data by providing the venue detail or the contact details or the confirmed case details. And that request, again, goes through the Amazon API gateway and gets put on the SQS queue. And here we use the native integration between the API gateway and the SQS, so there is no need to have a Lambda in between. And this asynchronous capturing of the request allowed us to rerun the extraction process if there is any issue, and that improves the reliability of the extraction process altogether. So just to walk through the process, as soon as there is a new request in the SQS queue, the Lambda function would be invoked. It will read the request, and depending upon the criteria, it will query and identify the records from the check-in DB, and also enrich that information by calling some external APIs, generate the extract in the CSV format, and put it into the S3 bucket as a staging area. Now, to pick up from the S3 bucket, we use the event-driven serverless approach, where we hooked in a Lambda function, which will be triggered as soon as there is a new file in the bucket, and it will transfer extract that file into the health system. So another practice we follow at Service is we are constantly listening towards the feedback from our community and from our citizen. And one of the very common feedback or sentiment we got that they wanted to access their history, the check-in history, and wanted to check out later from that. And what that means is like, imagine if you are in the shopping plaza and you are hopping through different shops and you are checking in through different shops. They wanted to check out at the end when they have left the plaza. So to support that, we have built that feature, that functionality in our mobile app, and we have created a RESTful serverless API using the Amazon API gateway and the Lambda function to query a given customer check-ins from the check-in DB. We also combined the check-in information with the hotspot information provided by the Health New South Wales, and that allowed us to let the customer know if they made a check-in during the hotspot window. So that's the red banner or the flag they will see in their check-in if there was a potential exposure. Now, we also worked very closely with our contact tracing team to find out the opportunities where we can improve the efficiency of the overall contact tracing process and scale that out when we had the different the COVID waves. And for that, we expanded the self-service portal and allowed our contact tracing team to provide the list of confirmed cases, upload it into the system, that goes into the S3 bucket, and from there, the Lambda function writes that CSV, each record, into the DynamoDB table, where we have the stream enabled. And what that means is that any record inserted into the DynamoDB table would also be available in the stream as an event for the further processing. And this pattern really allowed us to scale the processing of individual rows from the CSV or the record from CSV in parallel to reduce the overall processing time. So it was we created a multi-step process. So in this step one, the hotspot detection system is going to consume that information, the confirmed case details, look into the check-in DB, and identify those venues which needs to be marked as a hotspot, and put that information into the hotspot DB. Then in this step two, the close contact identification function is going to consume those hotspot events and find out the potentially impacted customers whom we want to notify. Then in this step three, the notification function is going to consume that close contact information, find out their contact details, and use our in-house notification service to notify them through the SMS, push, and email about the health advice and isolation guidelines. So just to summarize what we have talked through so far. So we built a reliable and robust contact tracing platform to allow our citizens to safely and securely provide their check-in information only for the contact tracing purposes. We also built a self-service portal for our contact tracing team to easily and quickly request access to the data. We integrated this contact tracing solution with our robust identity management system, and that allows us to keep the contact information and the check-in information separately, and hence improving the security and privacy of the solution. We use different AWS services as a building blocks, like Amazon Lambda function, DynamoDB, API gateway, application load balancer, SQS, and others. And by using these services as building blocks, it allowed us to inherit the security, performance, and reliability of these services into our solution. And we used our past experience and expertise in building these serverless solutions at Service New South Wales. And that allows us to really quickly set up the new solution just in 3 weeks without compromising the security and the privacy of our customer data. So I think we can't finish any presentation without talking through the numbers. So here are some numbers which we would like to talk through. So since the launch, we have captured around 700 million check-ins or QR code scans, and that includes just the check-in, not the checkout or the check-in history and other requests. And these stats were put together at the time when we created the slide, so the system is still running and still capturing more. During the peak usage of the system, we were on an average daily recording around 10 million check-ins, and that was the load on the system. During the peak time, we observed around 750 requests per second or scan per second as the throughput we were supporting. And the system really scaled automatically to meet that demand without any manual intervention or without any human involvement. And as I talked about that, we have a robust customer feedback collection channel, and through that, we got around 97% of the satisfaction, and like thumbs up. So that means that the community really liked the solution. And as I mentioned before, the time to market for our first phase one of the solution was 3 weeks. So we were really able to quickly react on this circumstance or in this scenario to deliver something quickly in the community. And I think now I would call Moha on the stage to wrap up. Thank you.
Amazing, amazing work. Thank you, Alvin, and thank you, Carol. So as we've seen, our heroes at Service in South Wales, they've mentioned a few building blocks or serverless services from AWS. If you would like to learn more about these services or other AWS services, we invite you to head to Skill Builder, which you've seen in the keynote. Scan the QR code or go to skillbuilder.aws. It's our online learning platform that provides on-demand, self-paced digital courses in up to 16 languages. We also encourage you to aim for certificates, one of our 12 industry-recognized AWS certifications. Scan the QR codes. Now, were there any questions to our speakers? I've got a question there.
Thank you. That was amazing. I have a couple of questions about the architecture. So I've noticed that some of the services was using the AWS services, and some other options you guys use something else like Kafka, for example. So what drove you to use Kafka versus something like Kinesis of Eventbridge? So you go full in with the AWS. Thank you.
Yeah, I'll probably take that, Gary. Yeah, that's a good question, and thanks. You noticed that. So I think one of the reasons we went with Kafka is that at Service, we have a very big adoption on the event-driven and the streaming solution design. And as part of that, we already had the experience and the comfort using the Kafka cluster, in-house Kafka cluster. And because of this, the time pressure we had to build that solution, we just hooked in the serverless ingestion layer with that to quickly, just reuse the capabilities what we had. But then when we moved towards the extension of that solution, where using the DynamoDB stream, which is another the Kafka stream or Kinesis stream kind of capability, we thought that it makes sense to use that native capability rather than integrating with the Kafka again.
Thank you, Arvind. There's a question there at the back.
Yeah, I think that's another a good stat. So we were really worried about the compute it's going to cost us, and when we looked through the bills, I think to support this 10 million request for the entire day, for the whole month, the Lambda was just costing around 100 Australian dollars a month. So that was really nothing for the ingestion layer.
For 10 million records.
10 million records every day. The ingestion, and during the peak time, as I mentioned, 750. So we noticed that to support that 750 requests per second, once there were 1,500 concurrent Lambda instances running in our accounts, and this was like really, interesting stats for us.
Amazing, amazing. Any more questions? Can't see properly, but I think there is a hand there.
It's a question about the architecture. So I think Lambda support, you have the high scalability when in the peak hours. But how did you deal with the DynamoDB layer? So it's like, did DynamoDB support scalability as well?
Yeah. So I think most of the serverless services we used in the solution, they all pretty much support the scalability out of the box. So hence the DynamoDB as well. And we actually used the auto scaling in the DynamoDB throughput. And I think that's not very new feature, but I think that really help us not to worry too much about the provision throughput up front. So that really scale, whatever the write throughput and read throughput we wanted, it scales to beat the demand, and we were charged accordingly.
Amazing. So you've linked auto-scaling to scale up and down the read and writes.
Yeah, that's
throughput
right.
of DynamoDB. That's amazing, amazing work. All right, we're sort of out of time now, so we'll wrap up. Please take some time, fill in the survey, please. We want to know, we appreciate your feedback, and we want to know what to improve on. And thank you very much. Please put your hands together for Carol and Arvind.
Thank you.
Thanks, guys.